Today we're going to talk about multiplicities. Before we begin, let's look at this given polynomial. Let's go ahead and factor this. This can be written as f of x equals x minus 1 times x minus 1, which we can further simplify as x minus 1 squared. Since there are two of these factors, x minus 1 has a multiplicity of 2 because there are two of them. Now, if you wanted to solve this, x minus 1, you set it equal to 0. You get x is 1. So if I were to graph this, I would have a point at 1, and it's a U shape. So there is one unique root because there is only one x-intercept, even though I have two factors. They're just the same. So let's talk about multiplicity. If a linear factor, just like the one we had here, is repeated n times, then that corresponding 0 has multiplicity of n. So in this case, it was repeated twice, so the multiplicity was 2. If this was repeated 3 times, then the multiplicity would be 3. Okay? All right. So let's talk about what your graph will look like when you have an even multiplicity. So if your multiplicity is even, that means your graph will be tangent to the 0. If your multiplicity is odd, the graph will pass through the point. Let's talk about what this means. Here's an example. This, if you multiplied all of this together, this would be a degree 8 polynomial. I'm sorry, this would be a degree of 9. The reason why we get 9 is you add up all of your exponents. 2 plus 3 plus 4 is 9. So that means your graph will look similar to this parent function because this is an odd degree polynomial. So this is what your parent function would look like. So let's look. The 0 for our first factor is x equals 0. This one is x equals negative 1. This one is x equals 5. So I'm going to draw my zeros right here. I have 0, I have a 0 at negative 1, and I have a 0 at 5. Because this is an odd degree polynomial, I know that my endpoints will look like this. Now let's talk about the multiplicities. Going back here, if the multiplicity of a 0 is even, then the graph of f of x is tangent to the 0. It will touch the point, but it will not go through it. However, if it is odd, then it will pass through the point. So let's see what this would look like. Here at negative 1. At negative 1, the multiplicity is odd. Your multiplicity was 3. So that means you're going to go through the point. So I'm going to draw my line. I'm going to go through it. At 0, my multiplicity was 2. 2 is even. So I'm going to be tangent to it. I'm going to touch it, but not go through it. And then at 5, your multiplicity was 4. That's even. So again, you're just going to bounce on it. You're not going to touch it. You're just going to, you're not going to go through it. You're just going to touch it. So that's what your graph looks like. Here's another example. This is a degree of 3 plus 2 plus 1 is 6. That means your graph will look like this. Your endpoints will be going the same direction. So if I were to graph this 0 is x equals 0. This is x equals 1. This is x equals negative 1. So I will have points right here at 1 and negative 1. And I know my graph has to look like this on my endpoints. So here at negative 1, my multiplicity was even. So I'm just going to bounce on it. At 0, my multiplicity was odd. So I'm going to go through that point. And at +1, my multiplicity was odd. 3 is odd. So I'm going to go through it. So that's what my line would look like. Okay, so on today's assignment, you're going to get a table like this. Notice, these are my factors. They're going to ask for the multiplicity of the linear factors. All of these are linear. They have a single x, so these are linear. This multiplicity is 1. You only have one x here. Here, I have 3 linear factors. And for this one, the multiplicity is 2 because I have 2 of them. Complex zeros. This is a 6th-degree polynomial. That means I'm going to have 6 complex zeros. However, I only had 1, 2, 3 unique zeros because some of them were repeated. I have 1, 2, 3 unique zeros. Let's look at an example that you're also going to get. So we're going to factor this. I'm going to have 2 numbers that multiply to 9 but add to 6. That's 3 and 3. So we can write this as x to the 4th plus 3x squared plus 3x squared plus 9. Notice 6x squared is the same thing as 3 plus 3 with the x squareds. So we didn't change anything. This is the same as this. Now we're going to split it down the middle and solve. So I'm going to do the GCF of both sides. These can both be divided by x squared. So I am left with this. We can divide both of these by 3. Whatever matches goes in one parentheses, and whatever is on the outside will go in its own parentheses. So this can be written as x squared plus 3 squared because I have 2 of them. Now notice, this is not linear. So if I went back to this table where it asks for multiplicity of linear factors, I'll go ahead and put my answer here, x squared plus 3, and it was squared. I don't have any. This is quadratic. So if the question asked multiplicity of quadratic factors, then the answer would be 2, because I have 2 quadratic factors. Now, let's go back to the previous slide to figure out complex zeros. This is a degree 4 polynomial. So that means I would have 4 complex zeros. Okay? Unique complex zeros. Well, if I wanted to solve this, you just set this equal to 0 and you solve it. So this would be x squared equals -3. And you would square root both sides. So you get x equals plus or minus I to the square root of 3. These are your 2 solutions. So you get 2 unique solutions. Because you have a quadratic in here. So you're going to have 2 unique solutions. Here, these are all 1s. So this is 1 unique solution, 1 unique solution, and another unique solution. That made 3. Okay. Okay, so I'm going to divide all of these by x squared. So x squared will be on the outside, and what's left over is x to the 4th power minus 8x squared plus 16. I can do an eye chart from here. 2 numbers that multiply to 16 and add to -8, what will those be? -4 and -4. So this will be, x squared is still on the outside. I'll have x to the 4th power minus, I'm going to rewrite -8 as -4. and -4. Okay, and then plus 16. So we just rewrote this middle term. We split it into 2. Now I'm going to do the GCF of both sides. So I'm going to divide this side by an x squared. So x squared is on the outside, and I have x minus 4. And then this side, I can divide these. Oh, sorry, this is x squared. You guys see that? X to the 4th divided by x squared is x squared. Okay, and then I can divide these two by -4. So -4 will be on the outside. I'm left with x squared minus 4. So whatever matches, I know I did this correctly because I have 2 parentheses that already match. What already matches goes into 1 parenthesis, and what is on the outside goes in another parentheses. And guys, don't forget about this x squared that we had on the outside. I'm going to add that right here. So guys, this can be written as x squared minus 4 squared. Okay? So can you guys tell me what my solutions are? This one will be 0, x equals 0. And what will this one be? X equals... okay, let's solve it. Let's solve it. X squared minus 4 equals 0. You move the 4 to the other side, and then you square root both sides. So you get x equals, what's the square root of 4? And you get plus and minus 2. So 1 is 2, 1 is -2. But guys, that's only 3. Shouldn't I have more than that? Remember what my multiplicities are? What is the multiplicity for this 0? 2. And what are the multiplicities for these? 2, right? So this is 2 and 2, and this was 2. So that's 6 total, giving me my 6th degree. Okay? I just have 3 unique ones, but they're all repeated. That's why. Okay. So if I were to answer my table questions, let me write the table about this. This is my table. You guys see? Let me write this right here. Look right here. This is my factored form right here. This is my factored form. I want to know what is the multiplicity of the linear factor. This is my linear factor. I have 2 of them. So that's answer is 2. Is this linear? This is quadratic. I have 2 quadratics. Okay? So I'm not going to talk about the quadratics because I want to know the linear factor. Okay, complex zeros. How many zeros should I have total? 6, because it's a 6th degree polynomial. Some of them are repeated as we see. How many of them are unique? 3. You get 2 from a quadratic and you get 1 from a linear. So that's 3. And these were my answers. X equals 0, x equals 2, and x equals -2.